Good afternoon, Mira, Vasna, audible.
Yes, sir. You're audible.
So, the last week we just had one class where we finished up to subtraction of vectors. Now we'll continue with multiplication of vectors and then we'll start the electrostatics. Anyways, did you attempted that assignment that I shared with you?
Yes, sir.
Yes, sir.
That was doable?
Yes, sir. The 39th question I was not able to do.
39.
Seems 39.
At the end of the class, I'll discuss this. Now, the
Yes, sir.
last in vectors is multiplication of vectors. So, in multiplication of vectors, there are basically various type of multiplication. Vector with a number. You can multiply a vector with a number. Then you can multiply a vector with scalar. And the major part is multiplication of vector with vector. You can multiply a vector with a vector. Last one is vector with. These are the type of multiplication. So when you multiply a vector with a number, the thing is the final quantity will remain the same vector quantity. So let's say you have a vector A. You multiply this vector A with a number n. So this is NA if this number is positive. So that means nothing will change else than the magnitude of the vector. The magnitude will change. Magnitude will change. Direction and unit will remain same. Direction and unit will remain same. On the same case, if you multiply this vector with a negative number, minus n into it, you will get minus of n. Here also the magnitude will change, but along with the magnitude, now the direction get reversed. So magnitude change, magnitude changes, direction gets reversed. If you multiply a vector with a scalar, then magnitude changes, magnitude will change, unit will change, direction will remain same. Say if you are multiplying a mass with acceleration, mass is a scalar quantity, acceleration is a vector. So when you multiply mass and acceleration, the magnitude of acceleration is changing, its unit is changing, m into a have the units of force now, but the direction will remain same. But the actual thing is this: when you multiply a vector with a vector, there are two types of products. One is dot product and another is cross product. So we'll start with dot. Dot product is also known as scalar product. The reason is, say you have two vectors, a vector A and a vector B. They are inclined at some angle theta. So when you take the dot product of A and B, A dot B, what you will get is A dot B is simply its AB cos theta. Since final result is a scalar quantity, that's why we call it as a scalar. The result is a scalar, the dot product. Next, we have some properties of dot product. The first property is it's commutative, like it's A dot B is equal to B dot B. Just like normal multiplication, it commutes. Second property is if A is perpendicular to B, then the dot product of the vector is 0. Because if their perpendicular angle is 90 degree, cos 90 will be 0. Second. So for this perpendicular vectors, you can write like I dot j will comes out to be 0. If you write j dot k, then that this j dot k is 0. You can write this k dot I that comes out to be 0. Even if you switch the order, like instead of I dot j, you write j dot I or k dot j or I dot k to the same. Then the third property is if A is parallel to B, if vector A is parallel to vector B, then dot product is maximum. If you have two parallel vectors, then dot product is maximum. What is the angle between parallel vectors, Upasana?
0 degree.
0. If vectors are parallel means angle is 0 degree. So A dot B will be AB only because cos 0 is 1. So if you repeat it like I dot I will be equal to J dot J will be equal to K dot K, that will be equal to what if you have parallel. Then you should know dot product in Cartesian form. There is one more property like the distributive property. Like if you write this as A dot B plus C. You can take addition or subtraction. It's like distribution of normal addition or subtraction. So this is A dot B plus minus A dot C. Now, next is dot product in Cartesian. Dot product in Cartesian. So Cartesian form means you have a vector A, which is in terms of I cap, J cap, and K cap. So you have A1 I cap plus its A2 J cap plus its A3 K cap. Then you have a vector B, which is its B1 I cap plus its B2 J cap plus its B3 K cap. That's Cartesian. So when you take the dot product into Cartesian form, A dot B, then it will be just A1 B1 plus A2 B2 plus A3 B3. So you just multiply the corresponding components. A3 B3. Let's do few examples on dot product. For example, let's say two vectors are given. One is vector A, which is I cap minus 2j cap plus 3k cap. And then there is another vector, which is 2I cap plus 5j cap plus 6k. Let's calculate various parameters into it. Calculate first part. Angle between A and B. So vectors are given. We are supposed to calculate angle between vector A and vector B. Second one. Component vector of A. Component of vector A along vector B. So Meera will start from you. How will you calculate the angle between vector A and vector B? Vector A and vector B both are in Cartesian form. How do you calculate the angle between them?
So first we'll find the dot product A dot B, then divide by magnitude of A and magnitude of B. So we'll get cos theta, and then we'll take theta is equal to cos inverse.
So cos theta is simply its A dot B divided by its magnitude of A multiplied by the magnitude. So when we take A dot B, it's the coefficient of I cap is 1, coefficient of I cap is 2, so it's 1 into 2, 2. J cap is minus 2, J cap is 5, so it's minus 10. So its K cap is 3, K cap is 6, 18. Divided by the magnitude of A, so that's root over 9 plus 1, 10 plus 14, so it's root 14. Multiplied by its root of this thing. So this is 36 plus 440 plus 25. So this is 65. This is cos. So you can calculate theta is cos. Now, how will you calculate the component of vector A along B?
Unit vector of A dot.
So what you will do is you will take vector A. You will take dot product with the unit vector of B. A dot B cap is a vector or a scalar? G. A dot B cap is a vector quantity or a scalar quantity? It's a scalar, right? After dot, the result is a scalar always. So to make this component of vector, you have to multiply it with the direction of B also. That's B cap. So if in a question, if it is given component of A along B, that means take vector A, take its dot product with respect to vector B. This is the magnitude of the component. If you need component vector, then just multiply it with B cap. So vector A is its I cap minus 2j cap plus 3k cap. Dot B cap. So this is vector B and this is the magnitude of vector B, root 65. So we can write this as simply 2I cap plus 5j cap plus 6k cap divided by magnitude of root over 65. This is the magnitude of the components. For the component vector, just multiply it with one more B cap. So another B cap is 2I cap plus 5j cap plus 6k cap divided by root over 65. So when we take the dot product, the coefficient of I cap is 1, coefficient of I cap is 2, so here it's 2. J cap is minus 2, J cap is 5, so it's minus 10. K cap is 3, K cap is 6, so it's 18, divided by root over 65, multiplied by the same. So this is the component vector of A along the direction of A. You want to take the notes of this, or should I share the sheet, this link of this page?
You can share the links.
Upasana?
Yes, sir.
So this is the dot product. The type of question that you will get on only on dot product is these type of questions. Either it will ask you to calculate the angle, or it will ask you to calculate the component. Another type of question is two vectors are given which are perpendicular. You are supposed to calculate the unknown quantity. So if two vectors are perpendicular, that means dot product is 0. So I'm not going into that type of question. Next, we'll move on to cross product. So in cross product, if you have two vectors, one is vector A, another is vector B, the angle between these two. So when you take cross product, it's vector A cross vector B. This is A B sine theta into n cap. This n cap is the direction of A cross B, and n cap is perpendicular to both vector A and vector B. So it's perpendicular to both the vectors A as well as B. That's your n cap. Direction of n cap is given by right hand thumb rule. Direction of n cap is right hand thumb rule. It's given by right hand thumb. Now here the result is not a scalar. The result is a vector quantity. The cross product result is a vector quantity. Now if you take properties of cross product, in the first properties, it does not commute, it's anti-commute like A cross B is minus of B cross A. First property. Second property is if vectors are perpendicular, if A is perpendicular to B, then A cross B is maximum because angle is 90 degrees, sine 90 is 1. This will have maximum value. If vectors are parallel, like if A is parallel to B, then A cross B is 0. Sine 0 is 0, that's why A cross B will be 0. There is one more method to check whether the given vectors are parallel or not. If a vector A can be written as the multiple of vector B, lambda is any number, any real number. If you can write A as a multiple of B, that means A is parallel to B, is a real number. Huh? Is a real number, that means A is parallel. For example, if I write that I have a vector A, which is, let's say, I cap plus 2j cap plus 3k cap, and we have another vector B, which is I cap, let's say 3i cap plus 6j cap plus 9k cap. So it's clear that vector B is basically thrice of vector. So B is 3 times vector A. That means vectors are parallel. Now, if you want to do it in, there's another property, fourth one, distributive property. Like if you write this as A cross B plus minus C, then you can write this as it's A cross B plus minus A cross B. The next is cross product in Cartesian form. Like how will you calculate cross product in Cartesian? So in Cartesian form, to calculate cross product, we just make a determinant. So the first row is I cap, j cap, k cap. It's A1, A2, A3. Then you have B1, B2, B3. So this is how we calculate cross product if it is in Cartesian. Another is geometrical meaning of cross product. Geometrical meaning of cross product. In 12th, this topic is very useful for the problems in magnetics. Like when you have to calculate the magnetic moment of a current carrying coil. Does anyone remember the formula for magnetic moment of a current carrying coil? Mira, Pasna? Magnetic moment of a current carrying coil. No. Anyway, it's NIA. To calculate the magnetic moment, you need area vector. So in some cases, it's easy to calculate the area vector just by multiplication, but in few cases, you need this cross product to get the area vector. So you have a parallelogram. This is vector A and this is vector B. The adjacent sides are this, and you just complete the parallelogram. You need area of parallelogram. So to get the area of parallelogram is just the magnitude of vector A cross vector B. So I'm not repeating those questions which you have already done in your class 12 mathematics. You have vectors in mathematics also, no?
Yes, sir.
So I'm not repeating that question where the adjacent sides are given in the Cartesian form. I'm giving the question which is in class 12 NCRT in magnetics chapter number 4. So in NCRT, what is given? This is a coil is given. This is x-axis. This is y-axis. This is z-axis. In the actual question of NCRT, this is the z-axis, and you have this coil. It's placed in this way. This is the direction of current. This is the direction of current. Here I am saying this is the direction of vectors. This length is L. This length is B. This is B again. This is L. A, B, C. So this is a parallelogram if you are doing it in vectors, but when you are doing in magnetics, a current carrying coil. In magnetics, you are supposed to calculate the magnetic moment of this current carrying coil. Magnetic moment is nothing but NIA. A is area of the coil. To get the magnitude of this area is very easy, it's L into B only. But to get the direction of this area, it's very tough in this case if you are supposed to use the right hand thumb rule. If you can remember, in a current carrying coil, direction of magnetic moment is perpendicular to the plane of the coil. You remember this topic? No. Okay. So this is a current carrying coil. This is the direction. Just forget current carrying coil if you don't remember. Take this as vectors. You have certain vectors A, B, B, C, C, D, D, A. All these vectors are making a parallelogram. You are supposed to calculate the area of the parallelogram. To get the area of the parallelogram, and when I'm saying area as a vector. Otherwise, magnitude is easy, it's L into B. So get the value of area vector. What you have to do, you have to take cross of any two adjacent sides. Like you can take cross of AB and BC, you can take cross of BC and CD or DA. Anyways, I'm taking the cross of side BC, cross side CD. So BC is L. What is the direction of BC, Mira? Mira, what is the direction of
So
side
DC,
BC?
BC is downward, sir.
Downwards, minus J cap. Upasana, can you resolve this side B along X and Z axis? This is B, right? It's neither along X axis nor Z axis. Resolve this. One component should act along X axis and another should act along Z axis. Yeah. Simple resolution of vector.
BC cos theta. Like, sir, can you repeat the question?
Yeah, this is side CD, right?
Yes.
This is making some angle 30 degree with X axis. You have to resolve this side along positive X axis and Z axis. So this is B. This is B. If this length is B, then you're supposed to resolve this B along X axis and along Z axis. So what will the component of B along X axis I'm asking?
B cos theta.
B cos theta. Because if this is 30 degree, then it should be 30 degree. You take component, this is B cos 30, and along Z axis, this will be B sin 30. So in terms of vector form, I should write this as B cos 30 minus I cap, and this will be B sin 30 minus of K. And here it should be a cross product. Now I'm asked Upasana, just apply distributive property and take this cross product. What will be the answer? Upasana, cross of L of minus J cap and D cos 30 minus I cap. What would be the result? Mira?
Minus I cap.
Oh, see, this is L. Okay.
Oh, LB.
See, this is I cap, this is J cap, and this is K cap. If you are going into the clockwise direction, then this is positive. If you are going into anti-clockwise direction, then this is negative. Clockwise is positive. Anti-clockwise, if you are going, it's negative. Which means, first multiply the numbers. L is a number, B cos 30 is a number, negative and negative is positive. So this is LB, cos 30 is root 3 by 2. The cross product is in between two vectors only. One is J cap, another is I cap. So we'll write this as J cap. Then this with this, you're applying this distributive property. L into minus J cap multiplied with B sine 30 minus K cap. So this will be again LB sine 30 is half minus minus plus, it's J cross. Now Upasana, just use this diagram and tell me what is J cross.
K cap.
Upasana, just check. When you're going from J to I, you are going clockwise or anti-clockwise?
Anti-clockwise.
So it will be positive, negative,
Positive.
negative. So it's minus of plus this is LB by 2. What is J cross K?
I cap.
So this is your area. When you calculate magnetic moment, what you do, you will take just this area vector, you multiply it with the number of turns. So in magnetics, the magnetic moment is Ni. This is the question of NCERT back itself. There, along with the magnetic moment, you have to calculate torque also. Torque is M cross B. But to get everything, you need this area. So this is what you should know. Well, I think you should write this thing at least. This last example you should note down. If you open the NCERT of chapter number 4, I believe it's the second last question. Second last or third last question. Just tell me when you are done. We'll start with electrostatic. This is enough for vectors for now. We'll continue with electrostatic. Written?
Yes, sir.
Yes.
That was about vectors. I'll give some more questions, no more assignment. Next is we'll start with electrostatics. So in electrostatic, there's two chapters. One is electric charge and field. One is electric charge and field. Another one is electric potential and capacitance. We'll start with electric charges. So I'm not writing the basic definition of charge, what is charge, what is charging. We'll start with the method of charging. But before starting, can you tell me how you charge a body? What does charging mean? You have two objects. One is A, another one atom is A, another atom is B. This atom have 4 protons and it have 4 electrons. This have 3 protons and this have 3 electrons. Both the bodies are neutral. The charge on A is charge on a proton is plus E, so charge on 4 protons is plus 4E, 4 electrons is minus 4E, so the net charge is 0. Here also charge on 3 protons is plus 3E, charge on 3 electrons is minus 3E, net charge is 0. Now, if I ask you to charge atom A and charge atom B, what you will do? How will you charge a body?
By adding or losing of electrons.
We can charge a body by transfer of electrons. So body which becomes negatively charged, it will lose electrons or gain electrons?
Gain electrons.
Negatively charged body, it will gain electrons. And what will happen to its mass? To gain electrons, its mass will increase. If you have a positively charged body, this will lose electrons. Its mass will increase. Then we have methods of charging. There are 3 methods of charging. First is charging by friction. Second is charging by conduction. The third one is charging by induction. The only topic from which you can get question is charging by conduction. I'm not discussing charging by friction. Charging by friction, what we do, we just rub 2 objects. So the charge is transferred from one object to another. This is charging by friction. I'm not discussing it. Start with charging by conduction. So charging by conduction. Here in charging by conduction also, at this stage, we can discuss only the cases when 2 identical bodies are placed in contact. We can discuss only that case when identical bodies are connected. Now this connection could be of any type. It can be connected through a wire or connection is by their direct contact. We'll see. So if you have a body A, this has some plus 4E unit of charge. Then you have another body B. This body have, let's say, plus 8E unit of charge. And if both the bodies are identical, both the bodies are identical, A and B are identical, A and B are identical. So this is before connection. After connection, what will happen is when you connect A and B, then charge will flow from B to A until both have same charge. So the charge will get equally divided. This will have 4E plus 6E divided by 2. This will again have 4E plus 6E divided by 2. So this will have a charge of 5E. This will again have a charge of 5. That is the charging by conduction, which can be used in numericals. If bodies are not identical, if they are different, that we will discuss in capacitance. So to decide the charge distribution of bodies when they are not identical, then we need capacitance as well as potential. That we will do in charging capacitors, not here. Here we will discuss only about the identical bodies. So if 2 identical bodies are placed in contact, what happens? Charge gets equally divided. Charge gets equally divided. Charge gets equally divided. This is charging by conduction. After charging by conduction, there is charging by induction also. So induction, what happens is you have a body. This is conductor. This is a conductor. Near this conductor, you bring a glass rod. We call this glass rod as a inducing charge. This have 3 unit of positive charge. So this 3 unit of positive charge will attract 3 unit of negative charge of this glass rod and will repel 3 unit of positive charge. So these charges are known as induced charges. Inducing charges and induced charges are equal. There's one more thing that we'll use here, and that is earthing. Earthing means connecting a conductor with earth. This process is known as earthing. You take a conductor, it's a charged conductor. You connect this conductor with earth. When you connect this conductor with earth, if this charge is not attracted to any other container or conductor, then this charge will flow to the earth. That is known as earth. So if a conductor is earthed, that means its potential will become zero. Charge may or may not be zero. In this case, potential is zero as well as charge is zero. But the thumb rule is, if a conductor is earthed, then its potential will become zero. Charge may or may not be zero. After earthing, this is quantization of charge. Quantization of charge. Quantization of charge says if you have an object, the charge in that object could be an integral multiple of E only. Positive or negative, both charges on an object can be an integral multiple of n only, where n is an integer. The reason is, when you charge an object, you transfer electron. You can either transfer 1 electron or 2 electron or 3 electron or 4 electron. You can transfer electrons only in integer numbers. You can't transfer 3.5, 4.5, 5.5 electrons. That's why the charge as an object is also an integral multiple of it, where E is the electronic charge, which is 1.6 into 10 raised to the power minus 9. All these topics will be used in Coulomb's law. In JEE, it's not going to ask any question on just charging or just quantization. It will ask question on Coulomb's law or maybe some in electric field or anywhere else. It can use these topics. So the major electrostat starts from Coulomb's law. There are very good chances to get questions from Coulomb's law. So what Coulomb's law says? Coulomb's law says if you have two charges Q1 and Q2, they are placed at a separation R. The force between them will depend upon the product of charges. The force will depend upon the separation between them. And force will also depend upon the medium between the charges. When you combine everything, you write this expression as it's 1 over 4 pi epsilon naught. It's Q1, it's Q2 divided by R. This epsilon naught is absolute permittivity of free space. This is absolute permittivity of free space. Different mediums will have different permittivity. So if you place two charges in air, then we use the permittivity of air. If you place the same charges into conductor, then we're using the permittivity of conductor. Anyways, what is the permittivity of a conductor, conducting medium?
Infinity.
Infinite, right? That's why the force between two charges in a conductor is, this is absolute permittivity of free space. Its value is, it's 8.85 into 10 raised to the power minus 12. If you write its units, then this is Newton meter square per Coulomb square. Oh, sorry. Unit will be Coulomb square per meter square per meter is the unit of absolute velocity. Sometimes this 1 over 4 pi epsilon naught is represented by K and its value is 9 into 10 raised to the power 9 Newton meter square per Coulomb. This is when you write epsilon naught, that means you are writing the formula in free space. When you introduce a medium, then you write either as it's K epsilon naught Q1 Q2 by R square, or you write this as epsilon R epsilon, where this K is the dielectric constant. The small k is the dielectric constant. So this is the force between two charges in air, and this is a general formula which is valid for any medium. So if you want, you can write the force in a medium is force in air divided by the dielectric constant. And we are assuming that charges are placed at the same separation both in air and in medium. So force in medium is less than the force in air. And you should remember the dielectric constant of few mediums like K is equal to 1 for air. K is equal to infinite for a conductor. For water, its value is around 80. K is equal to 80 or 81 for water. Some people write this as 80, some will write this as 80. Okay, now there are certain characteristics of Coulomb's law, like Coulomb's law is valid only for point charges. This is valid only for point charges or spheres. It's valid only for point charges or spheres. It's valid for static charges. There is one exception. There's one exception where it can be applied for the moving charges as well. And the exception is if you have a charge which is at rest, one charge is at rest, and another is moving in a way that the separation between both the charges does not change. Means another charge is revolving around it, just like an atom. An atom, we apply Coulomb's law. So that's the exception. This is one exception. Otherwise, to apply Coulomb's law, both the charges should be static. They should not be. Electric force is conservative and central force. What does conservative means? Mira, what does conservative force mean?
So there is no change in kinetic energy.
No. Vasna, what is conservative force? See, conservative forces are very, very special forces in physics. These are the forces for which the concept of potential energy and potential is valid. If you don't have conservative force, you don't have potential, you don't have potential energy. The definition of conservative forces, work done is independent of that. Work done is independent of that. Independent of. And if you have a conservative force, then only you can write that change in potential energy is equal to work done by external force. This is again this valid for conservative force. The definition is this: work done is independent of that. So if you have a force which is non-conservative, then you can't use this relation. So electric force is both conservative as well as central. So I don't think there is anything that need to be written. Let's start with the problems very clear. Let's start with the first question. At least draw the rough sketch. I'm sharing the sheet with you. No need to write the entire question. Just draw the rough sketch of the question. Then we'll solve it together. First, read the question and draw the rough sketch. And tell me once you have drawn. Upasana, Meera, just tell me once you have drawn the rough sketch. Done? Are you able to draw the rough sketch of this question? Yes, no. If you're not able to draw, just say no, you will do what?
So I don't know if it's correct. Like the thread is making an angle with vertical. I'm confused with that sentence.
Okay. And Upasana, you?
No, sir.
See, Upasana, this is the support. From this support, two threads are connected. Two identical tennis balls, each having mass M and charge Q. So this have charge Q and mass M. Another ball have charge Q and mass M. Both are connected by the threads. The length of each thread is L. Both the threads make an angle theta with the vertical. This is vertical, this angle is theta, and this angle is also theta. Equilibrium. What does equilibrium means? Net force is zero, right? Equilibrium means net force is zero. So there are two terms from the mechanics. One is equilibrium, another is small angle. Small angle means tan theta, sin theta are equal, almost equal. Equilibrium means net force is zero. So let's start with any of the mass. Let's start with this mass. So what are the different forces which are acting on this mass M? First one is its weight, which is acting downwards, it's Mg. Second is the tension, it's acting in this direction. Then this positive charge will repel this positive charge, it will experience an electric force which is Fe. If this angle is theta, then this is also, you can resolve this tension into two parts. This will be T cos theta and this will be T sin theta. So when you solve it, you will get, if charge is in equilibrium, that means net force on the charge is zero. If net force is zero, that means net force along x-axis is also zero and net force along y-axis is also zero. So Basna, count how many forces are acting along x-axis? Number of forces along x-axis?
Two.
Two forces, right? T sin theta and Fe. So you can write this as T sin theta is equal to Fe. Similarly, Basna, tell me about y-axis. What are the forces acting along y-axis?
Two again. Two.
Sorry?
Two.
Two.
Cos.
What are they?
T cos theta and then mg.
T cos theta is equal to H. Just divide them. When you divide them, this tension will cancel this tension. You will get sin theta, tan theta is equal to Fe. Fe is electric force. To calculate this is Fe by Mg. That is one equation. We are supposed to calculate what is the equilibrium between make an angle theta with each other. So we are supposed to calculate this separation between them, and this separation of options is given as T. So we can write that tan theta is Fe. If I apply Coulomb's law, that is 1 over 4 pi epsilon naught. It's Q into Q, which is Q square divided by D square into H. So from here, you can calculate D square, which is Q square by 4 pi epsilon naught mg into tan theta. Now the problem is with the tan theta only. See, in none of the option tan theta is given. So you have somehow you have to calculate this tan theta. Now, if I come to this right angle triangle, How much is this side? The whole is D. How much is this one?
D by 2.
D
This
by
is D
2.
by 2. This is L. So if I want to calculate tan theta, then I have to calculate this also. I will need this side also. But since it's given that it's a small angle, so what I can do is I can just save my time. I can simply write this as tan theta will be almost equal to sine theta. And what is sine theta? Sine theta is perpendicular upon hypotenuse. So this is d by 2. So instead of tan theta, you can write d by 2. So when we do this, when we substitute this term over here, we will get d square as q square by 4 pi epsilon naught mg tan theta, which is d divided by 2. So we can divide this 4 by this 2. This L will come to the numerator and this d will get multiplied here. So we'll get d cube as q square L by 2 pi epsilon naught mg. So we get d is equal to q square L by 2 pi epsilon naught mg to the power 1 pi. Is there anything? Is it clear now?
Yes, sir.
If you look at past 10 years question, then you'll get 4 to 5 questions of the same concept. The same question, it's modified in various ways. Here it is placed in air, in another question it was placed in water. Then in other questions, these balls were there and the charge was leaking from both of them. The structure will remain same. Then there are some small modifications. I'll add those questions down to the side. Just wait on this. And try to do it on yourself. Like this, you should know this resolution. You should know how to divide it due to equilibrium. The homework assignment will get at least 4 or 5 questions based on the same concept. At the end, there are modifications. Here it's asking about the separation. Another question asking about the density. In some question asked dielectric constant. Just tell me when you have written. We have to discuss the doubt also.
Done, sir.
Whole question? Just this much of stress.
Done, sir. Done, sir.
Then there are few more questions. Today the class is for 1 hour only. Yes, class duration is just 1 hour. No?
Yes.
You wanted classes to be 1 hour till your biology exam, right? Both of you?
Yes, sir.
Yes, sir.
Okay, but after biology, we have to exceed the class timings, which otherwise we won't be able to finish the targets till your exam. Did you get the admit card, or any tentative date of exam? JEE?
No, sir. I did not
Wait,
check.
you did not check. Both of you didn't check.
No, sir, they didn't release our dates.
Also, along with JEE, are you going to apply for the NEET also?
Yes, sir.
Yes, sir.
Okay, in that case, let's talk for 1 hour today. I don't have assignment right now. I will just write the solution and share that with you. Huh? Question number 39. Share. Right? You have another class now.
Okay, sir.
Okay, but after your biology exam, we have to exceed the class timings to 2 hours. Otherwise, we'll miss the class.
Yes, sir. It's fine.
So, thank you.
Thank you, sir.
And I'm sharing the assignment to solve that assignment.